Our last example has us solving for a quantity with which we may not be familiar. It's called stress. We'll study this in much greater detail in a later chapter in the course. But we're told that stress in SI units is this newtons per meter squared. So it's a force per unit of area. And so in this circumstance, we have a cable that is supporting an engine, as we can see in our rudimentary diagram here. And so we want to determine what is the force that is being applied to this cable across its cross-sectional area. So in our need, we want to find the stress in the cable. And so what are the things that we know? Well, we know that the force is this half a ton. And we should take note that weight is a force. We'll study that in greater detail as well. So that is a force, so 0.50 tons is the force being applied to the cable due to the weight of the engine. We also know that the diameter of the cable is 0.50 inches. Should include that there as well. And the last thing that we've got is this conversion between 1 pound force and 4.45 newtons. So 1 pound, let's try that again. 1 pound force is equal to 4.45 newtons. And you'll notice that I'm writing it as 1 pound force because there is something called pound mass as well. We'll study that later. You'll probably cry real tears as a result. But that's all of our know, so now we want to figure out the solution to this. So again, if we really want to boil it down, we're looking for a calculation of force over area when we're all said and done. So we can kind of isolate things here a little bit. We'll start off with the force part of our calculation. So again, the weight of the truck is 0.5 tons. So we want to convert that into pound force. So tons to pounds, and then pounds to newtons. So I'm going to go ahead and convert that. So hopefully we know, again, we've got to be good Americans to know this stuff, that 1 ton is 2,000 pounds. And now we're going to use that conversion factor that we were given of 1 pound force is 4.45 newtons. So that's going to get our force into newtons when we're all said and done. And then we've got to work on the area. So for the area, hopefully we remember that the cross-sectional area, in this case for a cable, it's going to be round. So we're going to have to go with pi times radius squared. So I'm going to have to do pi times, I'm going to take my 0.50 inch diameter and divide it by 2 and square it. And so then I'm going to have to take those inches squared and convert them into meters, because I eventually need to have meters in the bottom. Well, I can do that through a series of calculations, converting inches to feet and then feet to meters from previous knowledge. Or I'm going to introduce a conversion factor here where we've got 1 inch is the equivalent of 0.0254 meters. Now again, I'm going to have to square that conversion factor because I'm ending up with inches squared here in my area calculation, and so I need to have inches squared in order for that to cancel out and to end up with meters squared in the bottom. And so to get our answer following significant figures rules, what we have here is just a ton, excuse the pun, of multiplication and division. So up top, again, just to make sure that our units work out, got the tons canceling out, got the pound force canceling out, we're ending up with newtons. On the bottom, got our inches squared and inches squared canceling out, but we're ending up with meters squared when we're all said and done. So if we push buttons on our calculator, up on the top, we're multiplying 0.5 times 2,000 times 4.45 Then we're dividing that by pi. We're dividing it by essentially 0.25 twice and by 0.0254 twice, since both of those quantities are squared. And then we round off to two significant figures. As we look at these measurements here, those were accurate to 2 sig figs. So we're going to end up with an answer of 3.5 times 10 to the 7th newtons per meter squared. Or we could have written it as 35 million if we wanted to write it in standard form. So again, no rounding at any point until we get to that very last number, and then we just take what we got on our calculator, round it off to 2 sig figs, and there's our result.